All right, so that was it. We've created a Pong clone. The final game took us about 220, 230 lines of code to implement. For a simple game engine like Pygame, that's remarkably short and a testament to Python's and Pygame's quality. Um, Having been through the experience, I hope that you agree that the code is quite readable. And more complex game engines like Unity or Unreal are more sophisticated, but still all the things that you've learned here, especially the event, update, draw paradigm, holds true. They just have more sophisticated methods for collision detection, and actually they also have built-in physics engines. So give them a test drive now that you know the basics behind game engines in general. Um, so what's left? Where do you go from here? Well, there are a couple of challenges that you can try to take on. One of them is add sound. Pygame supports sound, so make a noise when the paddle hits, when the ball hits the paddle. And another one is increase difficulty. So you can make the ball faster than when the longer it is in place, so that it becomes harder and harder. Uh, Make the paddles thinner, make the paddles faster. All these things you can try to what we call balance the game to achieve the right amount of difficulty so that it's not too frustrating but also not too boring. Last but not least, the original Pong, that's an interesting problem. The original Pong had the paddles divided into a couple of sections, and the angle of a return would actually vary depending on where the ball would hit the paddle, so that would add like a slicing effect from table tennis or something like that. So that can actually become quite involved because you have to find out where exactly the paddle's being hit. So, but that being said, I hope you had a fun experience walking through a classic video game development with me, and I hope we'll see you soon at Kentucky State University.